All right, good morning, good afternoon, good evening, wherever we are in our virtual world. My name is Ron Dagdag. I'm a lead software engineer at Spacey and a Microsoft MVP. Today, I will be talking about making neural networks portable with ONNX. All right, let's get started. Of course, my Slack messages have been coming through. Let's go back to programming. What is programming? Where you have input and algorithm. In this case, we're doing uh, at a calculator. We need some input. We need to figure out what the algorithm and we spit out the answers. In machine learning, it's like the other way around. The goal is to be able to teach the computer how to generate an algorithm for us. So what do we need in order to generate algorithm? We need inputs and lots of examples and lots of answers to be able to get the algorithm going, generate it. So as a machine learning primer, programming on the right, machine learning on the left, where you have your answers, input, and algorithm. In machine learning world, we call that training data. And then, of course, you need the training framework in order to generate the model for you. And then, of course, so a lot of us here are developers. The model we would use to replace our algorithm, and then it closes the loop and be able to integrate it with our programs. In machine learning world, you would need, that's what we call inferencing. And then you would need an inferencing runtime in order to use that model. And then, of course, it's a feedback loop to improve your machine learning model. All right, so of course, if you're familiar with JavaScript, you've heard about a lot of the JavaScript frameworks and all these different frameworks that is pretty much coming out every week, every few months. In AI and machine learning world, there's also a bunch of those. There's a bunch of frameworks and trying to understand the different tools and what you would use, or which one to be able to create your models. And of course, there's different ways in how you would deploy these models and where you would run it. Sometimes on your computer, sometimes you want to run it on the cloud, sometimes you want it on the phone, integrate AI models on the phone. Sometimes you want to run it in the CPU, the GPU, VPU, depends on what you're trying to do. There's a lot of ways how you would run and implement and integrate that machine learning model. And that's what ONNX does. Think about it as a PDF, right? You can write a Word document, convert it to PDF, and now PDF you can share it with a lot of people because you can have different viewers that are available out there. There's different ways in how we view it. It would be the same way as what we have for interoperable AI for ONNX. ONNX means Open Neural Network Exchange. It's an open format for ML models. Best place to go is to github.com/ONNX or ONNX AI. When should you use it? If you have something that's trained in Python, now you need to integrate it with your JavaScript application or C# application. Yes, ONNX is the best place to use that. If you want something really fast and high, and you need less latency for production use. If you want to run it on an IoT edge device, or you want to run it on a different OS or different hardware, ONNX is the best place to use. When you're trying to combine different models, let's say you have a data scientist, they're really good at a TensorFlow, another data scientist, you're really good at PyTorch, they develop all these different models. How do you integrate it with your application? ONNX is the best way to be able to do this and convert them all to ONNX. Then now you'll have one framework to be able to run those to do inferencing. And of course, if you want, when training takes longer, sometimes you can also do training at the edge using ONNX. So two steps in order to do this: you create an ONNX model, you deploy an ONNX model. Right? How do you deploy it? Let's start with how to create. The easiest way is find one that is existing out there. It's on GitHub. There's models that are available. You can download a lot of, if we're talking about ResNet, SqueezeNet, a lot of these open source not open source, a lot of models that is out there that's already been developed have been converted to ONNX. Another one is using custom vision, where you upload the files, upload some photos and label, do the training, and then you export it to an ONNX model. So customvision.ai. Another way is to, a lot of these frameworks that is available out there, PyTorch, scikit-learn, or Keras and all that, have converters that would convert the existing model into an ONNX model. So that's well worth looking into. And now, how would you deploy it? Best way to deploy it is using integrated with your application is using ONNX runtime. It's a high-performance inference engine for ONNX models. It's open source by Microsoft under MIT license, and you go to onnxruntime.ai to be able to learn more about it. If you go there, if you want to run it in Linux and you're doing a C# application and it's an 64-bit and you want to run it with hardware acceleration with CUDA, it tells you installation instructions, what NuGet package you would incorporate to your application, and then the document, then some documentation how you would run that. It's also available for JavaScript. If you want to use it in JavaScript or Node, there's ONNX Runtime Web to be able to incorporate it that runs on the browser itself, or you can run it in Node on the server, on the web server. So it's using WebAssembly and WebGL technologies, so it will both run with CPUs and GPUs. It is Chrome, Edge, Safari, Electron, Node.js compatible, Windows 10, Mac OS, Ubuntu. It just opens up a lot of things that you can integrate, machine learning models into your application. If you're a Windows developer, WinML API allows you to it actually runs on top of ONNX runtime. It allows you to integrate it to Windows Forms. So it's well worth looking into especially if you have a Windows Forms application and you want to run and add AI to it. If you want to learn more about my presentation and some examples, I have it on my GitHub page. Take a picture of this one. And once you realize the power of what ONNX can do, it opens up your mind of all these different applications. The value of AI depends on depends on us software developers integrating these models into our application. And that's what we can deliver the best value and best use case for these. So I would recommend looking into that. Just a quick sample, since I have a little bit of time. I'll show you how to use this using Node. Using Node, you would use ONNX runtime Node in order to do this, and then be able to load your ONNX file using ort.inference session and create, pass in parameters to your model. So in this case, I know on that model there's 2 parameters that I need. In this case, I have to convert it to this ORT tensor. It allows me to pass in those values, and once those values are, and then I pass it to my session, I specify my parameters, and it'll give me the result value. And that's it. So if I run Node on this application, my input in this case 10, and then the model requires me to have these output salary, even though it's not needed. And then once I run it, it gives me the value. The data result of the tensor is these. So that's just a way to be able to to try it out and see what we can do with ONNX. So I recommend looking more into this ONNX runtime and ONNX.ai. My name is Ron Dagdag. The best place to contact me is Twitter and LinkedIn and email. If you want to know all my social links, http linktree /Ron Dagdag. Thank you very much, and I appreciate your time.